Hi, welcome everyone. In this video, we will talk about equations of motion, and we will learn what are the equations of motion, when to use each equation, and solving some problems. First of all, we have studied that if anybody moves with non-uniform velocity, it acquires acceleration, which is given by this equation Vf, A equal Vf minus Vi over delta t. A means acceleration, Vf means final velocity, Vi means initial velocity, and this is the time taken from the initial velocity to the final velocity. And the equations of motion is applied for any accelerated body. This is the condition of using equations of motion. They have to be applied for any accelerated body. Accelerated, that means the body moves with increasing or decreasing velocity. We have three equations of motion. First equation says that Vf equals Vi plus At. At means acceleration times the time. And this equation is derived from this relation, A equal Vf minus Vi over delta t. A times t means At. Negative Vi will go to the other side with the opposite sign, which is positive, and Vf will be there. Okay, this equation, Vf means final velocity, Vi means initial velocity, A means acceleration, T means time. Okay. And the second equation of motion start with D, displacement, equals Vit plus half A times T squared. D means displacement, Vi means initial velocity, T means time, half, which is constant value, A acceleration, T power 2 means time squared. Time squared. And the third equation of motion, 2AD equals Vf squared minus Vi squared. And sometimes no problem if you started with Vf squared minus Vi squared equals 2AD, the same. You will notice that the three equations are different from each other. For example, the first equation don't contain displacement. The second equation doesn't contain final velocity. The third equation doesn't contain time. And these are the three equations of motion. Let's learn how or when to use each equation by solving problems. By solving a problem, you will learn exactly when to use each equation. Example number 1. If an aeroplane lands on the runway where its velocity at the moment of touching the ground is 162 km per hour. In this case, you have to change the unit from kilometer per hour to meter per second. And this by multiplying the speed or the velocity times 5 over 18 equals 45 meter per second. This speed, so we have initial velocity equals 45 meter per second. Then it decelerates uniformly. Decelerates means you will write the acceleration with negative sign. When the body accelerates, so the acceleration will be positive, and when the body decelerates, the acceleration will be negative, so it will be negative 0.5 meter per second squared. So confirm that the units is uniform. Speed in meter per second, so acceleration will be meter per second squared, and time in second, and displacement in meter. Then the time taken by the aeroplane to stop. To stop means final velocity will be 0. So here we have final velocity equals 0. He needs a time. According to the given and unknown, we have final velocity, we have initial velocity, we have acceleration, and we need time. So the suitable equation here is the first equation of motion. So you will write the equation Vf equals Vi plus At. Vf equals 0. Vi equals 45. This positive sign will be negative because acceleration is negative 0.5, and time will be written t. 45 will go to the other side with negative sign. It will be negative 45 equals negative half t. T equals, we will move the negative half to the opposite side or to the other side by dividing. So t equals negative 45 divide negative half, so it will be 90 second. 90 second. So the answer will be 90 second. Take in consideration the time is always be positive. No time will be a negative sign. Time is always positive. Okay, another example. A body moves with a velocity of 20 meters per second. So as we learn, first of all, you have to write your given accurately. Body moves with velocity 20 meters per second, so this is the initial velocity. In the east direction, okay, let's imagine that the body, you have to take in consideration the direction also. The body moves in this direction, east. If it starts to move with an acceleration of 4 meters per second squared in the west direction, so the acceleration here will be in the opposite direction to the direction of motion, so the acceleration here will be negative 4 meters per second squared. Okay, this is a tricky question. You have to concentrate during solving the problems. Okay, this is negative sign. This is negative sign. When body moves in a direction and the acceleration will be in the opposite direction, so the acceleration will be in negative sign. So the magnitude and direction of the velocity after 10 seconds, the time is 10 seconds, will be, okay, he needs the magnitude and direction of velocity. He needs final velocity. So this is the unknown. We have 3 given and unknown. So we will use the first equation, which contains Vf equals Vi plus At. Vf equals 20. Vf equals Vi equals 20, plus will be negative because the acceleration is negative, times t, which is 10, equals 20 minus 40 equals negative 20 meter per second. Okay, the answer here will be 20. So C and D are wrong. 20 in the east direction or west direction. The negative sign here in the answer means opposite to the direction, opposite direction to the direction of the velocity. So the direction of velocity in east, so it will be negative 20, so it will be in the opposite direction, which is west, 20 meter per second in west direction. The third problem, a body moves in a straight line with a uniform velocity of 4 meters per second. So this is uniform velocity means acceleration equals 0 in this period. Then it starts to move with uniform acceleration of 4 meters per second for 8 seconds. So we have here initial velocity is 4 meters per second, because we will start from this velocity, because he mentioned here that the body, after moving uniform velocity 4 meters per second, it was moving uniform velocity was 4 meters per second. So the acceleration here is 0. Then start to move with acceleration. So the velocity will increase. So we have started from 4 meters per second. And the acceleration is 4 meters per second squared. Time is 8 seconds. So the displacement of the body during its during this interval, displacement equals what? So here we will use the second equation. We have initial velocity, we have time, we have acceleration, and we need displacement. And not necessarily when using the second equation, not necessarily he needs displacement. Sometimes he needs initial velocity and you have displacement and time and acceleration. Okay? So by writing the equation, d equal vi t plus half at squared, then we will substitute displacement equals vi equals 4, time equals 8 plus half, acceleration is 4 meters per second in positive because the acceleration is the same direction of motion, times time squared, time equals 8 power 2 equals 160 meter. So the answer here will be 160 meter. In this example, a body moves in a straight line with uniform velocity of 4 meters per second for 8 seconds. So here he moved 4 meters per second with uniform velocity. So in this period the acceleration was 0, the speed or velocity was 4 meters per second, for time 8 seconds. You have to draw the problem. Then it moves in the same direction with uniform acceleration of 4 meters per second squared. So the initial velocity that we will start here with will be 4 meters per second. So the initial velocity here in the second period, when the body will accelerate, the initial velocity here will be 4 meters per second. And the time in the second period will be 6 seconds. So the total distance covered by the body. Here we have two rules to use. In the first period the acceleration was 0. So to find the displacement we will use this rule. Velocity equals displacement over time. So displacement equal v times t. Displacement equals velocity times time, which is 8, equals 32 meter. In the second period, there is acceleration, and we have initial velocity, which is 4 meter per second. The velocity we will start with was the velocity that the body was moving with. So the initial velocity is 4 meter per second, and the time is 6 seconds. We have initial velocity, we have displacement, we have time, and we have acceleration, we have initial velocity, we have time, we need displacement. So we will use the second equation, which is VIT plus half AT power 2. Displacement here, VI equal 4 times T, which is 6, plus open bracket half times acceleration 4 times T, 6 power 2 equals 96. So the total displacement 96 meter equals 32 plus 96 equals total displacement equals 32 plus 96 equals 128 meter. A motorcyclist has started motion from rest. When a body started motion from rest, so the initial velocity is 0. So the initial velocity here is 0. In a straight line at a uniform acceleration of 0.5 meter per second squared. So its velocity will reach 7, so this is a final or the second velocity, 7 meter per second. You have to determine each given through a displacement of. So here, what are the given and what is the unknown? We have initial velocity, we have acceleration, we have final velocity, and we need displacement. So the suitable equation here is the third equation. We have acceleration, okay, we have initial velocity, we have final velocity, we need displacement. So you have to write the rule to AD equals VF squared minus VI squared. 2 is a constant times acceleration, which is half displacement, equals final velocity squared. We will substitute VF by 7 power 2 minus 0. 2 times half equal 1, so displacement equal 7 power 2 equals 49 meter. So the answer will be 49 meter. In this problem, you have to be very concentrated during solving this problem. A bullet collided with a static target. This is a static target, and we have a bullet with a velocity of 100 meter per second. So we have the initial velocity 100 meter per second. Then the bullet penetrated the target 1 meter deep. So the displacement here equals 1 meter till it stopped. Till it stopped means the final velocity equals 0. So the average acceleration by which the bullet moved inside the target equals acceleration equals. First of all, when the velocity decreases, so the body is decelerating, so the acceleration, it has to be in negative sign. Okay, the acceleration, as long as the body is decelerating or the velocity decreases, or the body stopped, so the acceleration will be negative, so we have to exclude these answers, so the answer will be a negative sign. Okay, let's solve this problem. Which equation will be suitable for solving this problem? We have we need acceleration, we have displacement, we have initial velocity, we have final velocity. So the suitable equation is the third equation, minus vi squared. Okay, let's substitute. 2 is a constant. Acceleration, we need acceleration. Displacement equal 1. Final velocity is 0 because the body stopped. Initial velocity is 100 power 2. So 100 power 2 equals 10,000, and 2 will go to the other side. Will be there. So acceleration equals negative 10,000 over 2 equals negative 5,000, which means negative 5 times 1,000, we have 3 zeros, 10 power 3 meter per second squared. So the answer will be number D. I hope to get benefit from this video. See you later. Bye bye.